So here I am again at ESA STEC in Noordwijk. I cannot pronounce it correctly, but here I am with Daniel Mueller, who is the project scientist for both the SOHO missions and the Solar Orbiter mission to our sun, which has just recently made some incredible images of the sun's south pole. And we are standing in front of a scale model, I assume, of the Solar Orbiter. Is that correct, Daniel?
That's correct. This is a scale 1:6 model. So the real spacecraft is a factor of 6 larger in all dimensions.
And the spacecraft is a joint NASA mission, rather. 70% ESA funding for the spacecraft and launch with 30% NASA participation. Is that right?
That's correct.
Okay. And I think you said it was about 1.3 billion euros or dollars?
On the order of $1.2 billion at 2020 monetary value.
So last week there was a news flap. Your spacecraft, this ESA NASA spacecraft, made the first observations of either pole of the sun that have ever been polar regions. Let's be specific, because if you could explain that. What surprised you about these observations from the south polar region of our sun?
Right, so Solar Orbiter used planet Venus to swing out of the ecliptic plane where all the planets move. And so we got the first real view of the solar polar regions. And the first thing that we see now is that the sun is indeed looking as we expect it to look at the maximum of solar activity, with a very complex magnetic field at the poles. When the magnetic field is of unipolar structure, that happens typically at the minimum activity of a cycle, and right now we're at maximum activity, so that means there's a complex north-south magnetic polarity mixed present at both poles.
And your spacecraft is carrying 10 instruments?
Right. Solar Orbiter is carrying 10 instruments, 6 that observe the sun remotely, like telescopes and spectrometers, and 4 in situ instruments that measure the solar wind, like sticking a finger in the wind as we fly through it. And
this is just the beginning of a big download of data from the South Pole, and you successfully made observations of the North Pole, but that data hasn't been downlinked yet. Is that correct?
Right. So Solar Orbiter, like all bodies that orbit the sun, is on an elliptic orbit. Ours is very elliptic, so egg-shaped. So we had a period where we are close to the sun and also out of the ecliptic. And right now we are almost behind the sun as seen from Earth, so really far away. And so the data download goes down to a trickle, and it comes back starting in August. And then by early October, we expect to have downloaded all the data from this spring.
And when will we have new news about the data? How long does it take you to analyze the data once it's downloaded?
I expect that within a matter of 2 to 3 months after the data is on the ground, the first scientific results will have been written up and submitted to journals for publication.
So by the end of this year, we should have interesting articles, perhaps in Nature or Astrophysical Journal, about the solar, our sun's solar regions that we didn't have before this mission.
I would say by the end of the year, the first papers will be ready to be submitted or have been submitted to journals. And then the key thing about science is you have a review process where other scientists review the content and see whether the research has been done properly. So probably early 2026 is when the first papers will come out.
So the SOHO mission has been operational since late 95, December of 95. Or actually, it was launched in December of 95. Is that correct?
Yeah, the SOHO mission, the Solar and Heliospheric Observatory, which is another cooperation between ESA and NASA, was launched indeed 30 years ago. We'll celebrate the 30th launch anniversary in December of this year. It's been producing data for 30 years, and it's still active. In particular, the coronagraph data is still being used on a daily basis for space weather forecasting. And, we still have some operations left. Eventually, probably in the fall of this year, there will be a space weather follow-up mission led by NOAA if that mission is operational, then eventually it's time for SOHO to retire. But for the time being, SOHO is still producing unique data that scientists use every day.
And then the Solar Orbiter is due to continue, was launched in 2020, due to continue operation until end of 2026.
Right. Our current funding goes until end of 2026, and in this fall we start a budget renewal process. So we request an extension of operations for 3 years, with an indicative extension for another 3 years. And because we had a picture-perfect launch provided by United Launch Alliance and NASA, we saved a lot of fuel. So the onboard fuel reserves are so large that we can keep going for a long time.
So what excites you most about the Solar Orbiter mission?
What excites me most is that it's our best view yet of our star, and it never stops to amaze me what level of detail you can see on the sun with our current instrumentation. So we can see scales down to about 200 kilometers on the sun. That is unique and shows us a lot of dynamics of our star, and that is fascinating. And the other thing that fascinates me is how these 10 different instruments work together. So this is probably the mission where the instrument teams from all these different instruments had to work together more than in the past. So we do joint observing campaigns, and it's a real team effort to optimize the data taking and say, okay, we want to address this scientific question. What data do we need from which instrument to answer the question?
So thank you so much, Daniel, for your time today. A busy day for you. Good luck in the future. We look forward to hearing more from ESA and the Solar Orbiter mission.